Okay, so today we're going to talk about sequences and specifically arithmetic sequences. So far we have talked about sequences and we learned some function notation, something that would say like f of 2 equals 8, which would mean the second term was 8. All right, but today we're going to talk specifically about arithmetic sequences, which is a certain pattern, and it's defined by a pattern of addition and subtraction by a common difference. And this word common means that it's not just a pattern of addition and subtraction, but it has to be exactly the same addition and subtraction between successive terms. So like this first little pattern I have written here, for example, is plus 3, plus 3, plus 3. All right, so this one is arithmetic because you're adding a common difference of 3 every single time. All right, the next one, that one looks like minus 5, minus 5, minus 5. Even though it's subtraction, we kind of group addition and subtraction together, so that one's also going to be good. This last one, add 3, add 5, add 7, add 9. Now you may see the pattern there, because there is a pattern and you're adding odd numbers, but because the exact number that you're adding changes every single time, that is not going to be arithmetic. So it has to be the exact same every time. And then I just want us to remember explicit and recursive. So explicit was the formula where you could plug in. And remember, just like they all are, this is written like f of n. And recursive was the one that had the f of n minus 1. So the recursive formula had two parts. Usually it told me some starting value. So this is important for you to write down for what we're going to do today. So they somehow indicate a starting value. And they give me a formula that's f of n minus 1. And then we have some sort of pattern included here. And we talked a little bit on Friday. You all said it made more sense to almost think about the pattern instead of plugging stuff in. So hopefully that will help with how we're going to write some things today. All right, so I'm going to change one thing about these directions. This example asked me to construct an explicit rule for the sequence, and then it wants me to interpret the meaning of the specific term. The thing I want to add, I also want to add where we're going to construct the recursive rule, just so that you see an example of that, because you are going to need to know how to do that. All right, and before we start this example, you do probably need to copy this table down in your notes. But the big thing that I want us to talk about, or that I need to say before we start, is something weird about mathematicians. And that is that mathematicians start counting at 0. So what I mean by that is if a mathematician had, you know, five stars that he needed to count, 4, 5, instead of starting at 1, like you and I would start and say 1, 2, 3, 4, 5, the mathematician is going to start at 0 and say 0, 1, 2, 3, 4, 5. And that may seem silly to you, but it's important that you know that so that we can use that to move forward. So recursive rule, I think, is actually going to be just a little bit easier. So the recursive rule, let's do that one first. Remember, we need to say a starting point. And before we can do any of this, we actually need to figure out what is the pattern happening in this table. And if you take a second to look at your terms here, the pattern that's happening, it appears to be that they are adding, let's see, to me that looks like they're adding 12 every single time. And we can check and make sure that it works, but it does. They add 12 every time. So the recursive rule, remember, mathematicians start at 0, so I'm actually going to say f of 0 equals, and think if to go forward, you have to add 12. Well, if I was to try to go backwards and figure out what the 0 term is, then I would need to subtract 12, which means my 0 term is actually going to be 8. Okay, and then we need to write our rule. Well, we said it's add 12. So to write that with recursive notation, we just say f of n equals the previous number, and then my pattern, which is add 12. So there's my recursive rule. All right, my explicit rule. The explicit rule is almost a little bit easier if you kind of think about the word problems that we've done before. So the explicit rule, we want to think about where are we starting, And remember, we said we were going to start at 8 because mathematicians start counting at the 0 term. And then we want to add 12. And since we're adding 12, you have to think about this like it's a rate because we're doing that over and over and over again. For each term, you add 12, which means that I'm going to do plus 12n. All right. Now, to answer the final question, because we've written both of our rules now they want us to interpret the meaning of f of 10. They want us to find the value and determine that. Well, obviously, the easiest place to find f of 10 is to use the explicit because you can plug in. If you use recursive, remember, you got to count up all the way from, 0 now, 0 all the way to 10. So instead, we're going to use the explicit to find f of 10. 8 plus 12, and we're just plugging in here. So that's 8 plus 120, which is 128, f of 10. And then if we just kind of read the labels here, and we want to interpret the context, f of 10 equals 128 means at 10 hours, the distance will be 128 miles. All right, at 10 hours, the distance will be 128 miles. Okay, we will follow the directions here. Again, they want us to write an explicit rule, and they want me to use it to solve the problem. So if you notice our points over here, we kind of have a rule going on, and I can, we'll even make a table. So I've got the first term is 34, the second term is 51, the third term is 68, the fourth term is 85. So we just need to remember, mathematicians start counting at 0. My pattern moving forward appears to be plus 17. So to move backwards, I've got to do the opposite of that, which is minus 17, which makes my 0 term, this just happens to be the number 17 itself. So when I write my explicit rule, I want to say, where am I starting? So f of n equals my starting point plus my rate, which is, in this case, 17n. And then to solve the equation, I'm just going to find, it says 7 boxes. That's an x value, so I'm going to find f of 7 equals 17 plus 17 times 7. All right, that's going to give me 17 plus 119, which is going to give me 136. So what that means is that the height of 7 boxes stacked up would have been 136 inches. All right, last example. Again, we'll follow the directions here. We want to know the explicit rule, and we're going to use it to solve the problem. So Ruby signed up for a frequent flyer program. She receives 34,000 frequent flyer miles for the first round trip. All right, so if I were taking notes, you may not want to write down the whole problem, but I would at least do a bullet point and write down that first piece of information. And then she has 1,200 frequent flyer miles for all additional round trips. Okay, how many frequent flyer miles will she have after 5 round trips? So those first 2 pieces of information tell me some important things. If it says for the first round trip, that tells me around where I'm starting. That gives me a starting value. And then for all additional, that's telling me my rate. So if I write my explicit, I've got f of n equals, and actually I want to kind of correct something here. This says for the first round trip. So for the first one, she has 3,400. And then for each additional one, we're going to be adding 1,200. All right, that means for the next one, I'm going to have 4,600, and then if we add 1,200 again, that's going to give me 5,800. But remember, mathematicians start at 0, so that's why it's important, I guess, here to make a table so you don't forget to count backwards. So my 0 term then, if I subtract 1,200, is going to be 2,200. So when I go to write my formula, I've got my starting value, 2,200, plus my rate of 1,200 each time. So I'm going to put the variable there. And then how many frequent flyer miles will she have after 5 round trips? That's just asking me to solve f of 5. which with explicit, remember, that's really easy. You're just plugging into the equation you have written. All right, that's going to give me 2,200 plus 6,000. So f of 5 equals 8,200, which means after 5 trips, she will have 8,200 miles.